This is SpaceTime, Series 24, Episode 126, for broadcast on the 5th of November 2021. Coming up on SpaceTime, a new study suggests the Earth tipped over on its side 84 million years ago. NASA calling for new players to fly crews to the International Space Station. And has China just tested a hypersonic cruise missile, or is it, as Beijing suggests, simply a new type of spacecraft? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the Earth may have tipped over on its side 84 million years ago. The phenomenon, known as true polar wander, tilts planets relative to their spin axis, causing the geographic locations of the North and South Pole to change or wander. It happens because the mass distribution of the Earth isn't spherically symmetric, and the Earth has three different moments of inertia dominated by the spin axis. So what are we talking about? Well, the Earth consists of a solid metallic inner core, surrounded by a liquid metallic outer core, and that's encased in a mostly solid mantle with a thin crust on the surface. The entire planet spins once every day like a top on its axis through its solid inner core. But because the outer core is liquid, the surrounding mantle and crust can literally slip and slide all around the place, dominated by the location of the most amount of mass and density. And that would normally be subducting oceanic plates and massive volcanoes, which preferentially hang around 90 degrees to the spin axis, in other words around the equator. And of course weather and water movements can also induce small changes. But scientists aren't sure how often true polar wander happened to planet Earth. Now, a new study reported in the journal Nature Communications suggests the planet underwent true polar wander around 84 million years ago. The findings are based on bacteria fossils in limestone samples in central Italy's Apennine Mountains, dating back to the late Cretaceous between 100 million and 65 million years ago. These bacteria contain tiny magnetite crystals, and they form chains aligned to the planet's magnetic fields, thus providing a record of the planet's orientation. The researchers found a 12-degree southwards tilt in the Italian rocks, and thus the Earth itself, around 84 million years ago, which apparently corrected itself within about 5 million years. The findings paint a new picture of just how ephemeral the relationship is between the Earth's spin axis and its moments of inertia. This is SpaceTime. Still to come, NASA's calling for new players to fly crew to the International Space Station. And China is denying persistent reports that it's just tested a new hypersonic cruise missile, claiming instead the test involved a new type of reusable spacecraft. All that and more still to come on SpaceTime. The ongoing problems with Boeing's CST-100 Starliner spacecraft has forced NASA to call for other companies interested in providing crew transport services to the International Space Station. Boeing and SpaceX won the original multi-million-dollar contracts under NASA's Commercial Crew Program to fly an initial 12 missions carrying crew to and from the orbiting outpost. But while the SpaceX Dragon has performed well moving crew and cargo between Earth and the space station, Boeing suffered a string of problems with its Starliner, including parachute issues, software malfunctions, and propulsion system issues. In fact, Starliner is now 4 years behind schedule. SpaceX's Dragon, together with Northrop Grumman's Cygnus supply ships, are also transporting cargo to the space station under a separate contract. And they'll soon be joined by Sierra Nevada's Dream Chaser spaceplane, which will also fly cargo to the space station from next year using a cargo module called Shooting Star. Dream Chaser is a lifting body design. It'll launch aboard a United Launch Alliance Vulcan Centaur rocket, which will be replacing the current Atlas and Delta rockets from next year. And like SpaceX's Dragon cargo ship, Dream Chaser was originally designed to be human-rated in order to carry crew into orbit. and so there are better than even odds that Sierra Nevada will be applying for the new contract. This is SpaceTime. Still to come, China is denying persistent reports that it's just tested a new hypersonic cruise missile, claiming instead the test involved a new reusable spacecraft. And the Andromeda galaxy, the first exoplanet 51 Pegasi b, and the Orionids, Taurids and Leonids meteor showers are among the highlights we'll be discussing in November Skywatch. Beijing is denying reports that it's just tested a new hypersonic cruise missile, instead claiming the test involved a new reusable spacecraft. The Pentagon claims the missile was launched on a Long March rocket before circling the Earth in low orbit and then re-entering the atmosphere and narrowly missing its intended target. However, Beijing insists the test simply trialled a new reusable spacecraft. Having said that, China unveiled its DF-17 medium-range hypersonic cruise missile in 2019. It has a range of around 2,000 kilometres and can carry a thermonuclear warhead. However, this new hypersonic missile, if that's what it was, would have a far longer range, blurring the line between ballistic missiles which fly high into space in an arc to reach their targets hypersonically, and hypersonic cruise missiles, which fly hypersonically lower down in the atmosphere, potentially reaching their targets before anti-missile systems can respond, thereby making them difficult if not impossible to intercept. And China aren't alone. Russia recently test-fired its new Zircon hypersonic cruise missile from a submerged submarine. And Moscow has also been deploying its new nuclear-capable Avangard hypersonic missiles into active duty. The Avangard can fly up to Mach 27, changing course and altitude in mid-flight. This is SpaceTime. Time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. November is the 11th and penultimate month of the year in both the Julian and Gregorian calendars. It retained its name from the Latin Novem meaning 9 when January and February were added to the Roman calendar. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian Etruscan mythological winged horse who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are the spectral type M red stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then a Roman numeral is added to the end of all that to represent luminosity. Now, put all that together and a star like our Sun is known as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As for Epsilon Pegasi, Well, it's estimated to have about 12 times the mass of our Sun and about 185 times the Sun's radius. Epsilon Pegasi, together with the stars Markab, Al-Janib, Scheet, and Alpha Andromedae, form the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked-eye stars shaped like a huge square in the sky. One of the stars in the constellation is 51 Pegasi, which was the first main sequence star beyond our Sun to be discovered to host a planet. 51 Pegasi is a Sun-like star located 50.45 light-years away. Its planet, or more accurately exoplanet, meaning extrasolar planet, is designated 51 Pegasi b. The exoplanet's discovery was announced on October 6, 1995 in the journal Nature. It was detected using the radial velocity or so-called wobble method with a spectroscope used to detect very slight but regular Doppler shift changes in the star's spectral lines caused by the gravitational pull of the planet pulling the star one way and then the other as the planet orbits around it. 51 Pegasi b is about half the mass of Jupiter and orbits around its host star every 4 Earth days at a distance of just 7 million kilometers. At the time, a gas giant orbiting so closely around the star was something that had never been seen before, and this led to the creation of a new category of planets known as hot Jupiters, a category of gas giants thought to have formed further out from their host stars beyond the so-called snow line, but which then migrated inwards towards their current positions. The discovery led to the realization that the gas giants of our solar system, Jupiter and Saturn, also migrated inwards closer to the Sun during their early formation, something which explains many of the features of our own solar system, including the late heavy bombardment, the asteroid belt, and some unique characteristics of the ice giants Neptune and Uranus, as well as the mass distribution of the 4 inner terrestrial worlds, Mercury, Venus, Earth, and Mars. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located about 33,600 light-years away. Globular clusters are tight spheres containing thousands to millions of stars, all originally formed at the same time in the same molecular gas and dust cloud. Many are thought to be the cause of small galaxies that have been cannibalized by larger ones. Our own Milky Way galaxy contains at least 150 globular clusters. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains an estimated 100,000 stars, making it one of the most densely packed globular clusters in the Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars which appear to be surrounding what may well be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars, including 1 double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're away from city lights, you may notice a fuzzy patch in the sky right next to Pegasus. And that is the majestic giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in the local galactic group. It's located some 2.5 million light-years away. Estimates suggest it contains over 1 trillion stars, twice that of the Milky Way, and is some 220,000 light-years across. Now, if you can't see it too well, don't worry, it's getting closer every day. You see, the Milky Way and Andromeda galaxies are expected to collide in about 3.7 to 4.5 billion years from now, eventually merging to form what will be a new giant elliptical galaxy. Another case of galactic cannibalism in action. Now, based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also appears to have far less new star production than the Milky Way producing about 1 new solar mass star every year. And the rate of supernovae in the Milky Way is also about double the rate of Andromeda. Andromeda is surrounded by a large and massive halo of hot gas, estimated to contain about half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That means it reaches almost halfway out to the Milky Way. Now, using a good pair of binoculars or a small backyard telescope, you'll even get to see the dust lanes in Andromeda's spiral arms and its bright central galactic core, which contains a monster supermassive black hole. Now, located slightly to the east and south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. Beta Ceti or Deneb Katos is the brightest star in the constellation Cetus. It's an orange giant located about 96 light-years away. By the way, that name Deneb Katos, well, it means the whale's tail. One of the other stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 Earth days, changing in diameter from about 400 to 500 times the diameter of the Sun. Alpha Ceti, traditionally called Menkar the Nose, is a red-hued giant star some 220 light-years away. Now, it's actually a double star system, with the secondary star 93 Ceti being a blue-white star some 440 light-years away. Another double star is Gamma Ceti, the head of the whale. The primary is a yellow star 82 light-years from Earth, while the secondary is a blue star. At 11.9 light-years away, the yellow dwarf Tau Ceti is the nearest Sun-like star to the Earth other than the Sun. Okay, looking south of Cetus now, and you'll see the brilliant star Akana, which means the river's end, as it marks the end of the river Eridanus. Eridanus is the sixth largest of the modern constellations, and the one that extends furthest in the sky from north to south. Akana is a binary system, and the primary star Alpha Eridani actually consists of two stars, Alpha Eridani A and B, located some 139 light-years away. Of the 10 brightest stars in the night sky, Alpha Eridani is the hottest and bluest in colour. That's due to Akana being a spectral type B blue main sequence star. Akana also has an unusually rapid rotational velocity, causing it to become oblate in shape. The second star in the system is a smaller spectral type A white star, which orbits the primary at a distance of about 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or just over 8 light minutes. Now, if you follow Eridanus towards the east, you'll find the constellation Orion, a familiar signpost in the southern summer and northern winter skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova back on the 4th of July in the year 1054. They recorded the sudden appearance of a new star on their sky charts at exactly the position of the Crab Nebula. Their records show the supernova appeared brighter than the planet Venus for weeks on end, before finally fading from view after about 2 years. The shockwave from the Crab Nebula's supernova explosion is continuing to blast outwards, expanding at a rate of about 5 million kilometers per hour. At the heart of the nebula is a rapidly spinning neutron star, a pulsar, rotating at some 30 pulses per second. As it rotates, it shines a beam like a lighthouse beacon sweeping across the galaxy. This beam emits radiation at all wavelengths from gamma rays and X-rays right through ultraviolet, optical and infrared, even into the radio waves. Observations indicate the pulsar is slowing down and will fall to just half its current rotational rate in the next 1,000 years. November is also a great time to check out the Pleiades or Seven Sisters, one of the nearest open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus the Bull and are composed mostly of hot blue-white stars. Now, depending on whose measurements you prefer, the Pleiades are somewhere between 118 and 137 parsecs away, a parsec being around 3.26 light-years. The amazing thing about the Pleiades is that different cultures from vastly different parts of Earth have all described the Pleiades in the same way, as 7 women or 7 sisters. And this could possibly be some sort of ancient throwback to early human out-of-Africa civilization. Just like October, November sees 3 meteor showers. There's the November Orionids, the Taurids and the Leonids. Although peaking in late October, the Orionids are continuing to sprinkle down during the start of November, and are usually at their best during the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter. The Taurids meteor shower are generated by the comet Enki, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Enki and the Taurids are believed to be the remnants of a large comet which disintegrated between 20 and 30,000 years ago, breaking into several pieces and releasing material both by normal cometary ablation and also occasionally by close gravitational encounters with the Earth and other planets. In fact, the cometary stream of material left by Enki is the largest in the inner solar system. Being so spread out, the Earth takes several weeks to pass through it, causing an extended period of meteor activity compared to the much smaller periods of activity of other meteor showers. And further gravitational interactions with Jupiter have caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to November the 25th, while the northern Taurids go from October the 12th to December the 2nd. But the Taurids do have their downside. They're quite diffuse, usually only producing about 7 meteors an hour. However, they are composed of more massive material. Think of pebbles instead of dust grains. And so they tend to produce a high percentage of very bright meteors known as fireballs, produced as larger meteoroids burn through the atmosphere. The southern Taurids put on their best show just after midnight on November the 5th. Finally, there's the Leonid's meteor shower, which will peak on November the 18th. The Leonids are usually pretty reliable with 15 meteors an hour. However, they have been known to occasionally produce spectacular meteor storms, with showers in 1999, 2001 and 2002 producing an amazing 3,000 Leonids meteors an hour. Even more spectacular was the Leonid's meteor shower of 1966, which generated thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. They're produced by the debris stream from the comet Tempel-Tuttle. And as their name suggests, the Leonids radiate out from the constellation Leo the Lion. The Leonids are a fast-moving stream, which encounters the path of Earth at 72 km per second. Larger Leonids, which are about 10 mm across, can have a mass of half a gram, and are renowned for generating bright meteors. Scientists estimate the annual Leonid's meteor shower deposits between 12 and 13 tons of particles across the planet every year. And now, with a look at the rest of the November night skies on Skywatch, we're joined by Jonathan Alley, the editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, summer's just about here for us in the Southern Hemisphere. Days are getting longer and brighter and everything. The weather's getting warmer. Winter, of course, is coming for our friends up there in the north, in the Northern Hemisphere. But for us, it's summer. We do have to contend with daylight saving, which sort of messes up stargazing a little bit for some people. I mean, it doesn't actually change what you can see, but it changes the time of day. So anyway, we can deal with that. But anyway, let's see what's happening in the mid-evening sky in November from where we are. So if you go out there and have a look mid-evening, you'll see that the Milky Way is sort of hugging the horizon, in particular hugging the western horizon. So you need a clear sort of view out to the west, no trees and buildings and houses and things. And you'll see the tail of Scorpius, the constellation Scorpius, or some people call it Scorpio, just sticking up over the horizon. It's about to disappear from view. Scorpius is really a mid-year constellation. That's when you get the best views of it. So now we're in the end of the year. It's disappearing. The constellation Sagittarius is just next to Scorpius, so you can still see that for the moment above the western horizon. And when you look towards Sagittarius, you're looking in the direction of the centre of our Milky Way galaxy. Up in the north, if you look in the north half of the sky, for us in the southern hemisphere, or the southern half of the sky, people in the northern hemisphere, you'll see that it's filled with a bunch of big constellations that don't have many bright stars. You're talking Pegasus, you've got Pisces, there's a constellation called Cetus, which is the whale. You've got Aries, the ram. You've got one called Eridanus, which is the river, which is just a very long join the dots affair. It's a very long thing. I mean, you wouldn't even know it's there. It's just someone just joined the dots once. But a couple of things that you can see up in this part of the sky, if you've got very dark skies, are two distant galaxies. Now, we talk often on the program about some galaxies you can see only from the southern hemisphere called the Magellanic Clouds, and I'll get to those a bit later. But there are some other galaxies you can see, you can just make out with the naked eye if you have a good eyesight and a dark adapted eyesight. So you've gone outside and you let yourself adapt for a while, get used to the darkness. And if you don't have much light pollution around it, don't stand under street lights or something. But if you can manage all that, then you should be able to see just barely as a little smudge. There's the Andromeda galaxy and the Triangulum galaxy. Now, both of these are huge galaxies. They're very large, and together with the Milky Way, they make up the three largest galaxies in our so-called local group of galaxies. So
and Andromeda's getting a little bit bigger every day.
Yes, it's coming towards us very, very slowly in human terms, but yeah, it is a little bit. You can just make out these two galaxies as tiny smudges. Now, this might not sound impressive, but these are essentially the two most distant objects that you can ever see with your eyes. Okay, stars are nearby in space terms. They're tens or hundreds or thousands of light years away. We're talking millions of light years away here. Now, of course, with a telescope, you can see much further than that, and with the big professional telescopes, they can see right back towards the beginning of time, in the early days of the universe. But with just an unaided eye, these two galaxies are it. So if you get yourself a star map or an app of some kind, you can go out and try and spot these galaxies. I remember when I saw the Andromeda galaxy for the first time, I was really quite thrilled because Andromeda, back in the old days of science fiction, Andromeda was where all the nasty aliens used to come from. So it always had this sort of cachet about it. And I just thought it was fabulous to be able to go out and just see with my naked eyes, just a little smudge, thinking that is the furthest thing that anyone can see just with the unaided eye. And it's really quite amazing, I think, anyway. It's a bit like looking at Saturn for the first time through a telescope. You think, well, wow, there's actually this real planet. And when you think that it's, in the case of Saturn, hundreds of millions of kilometres away, it's just amazing, I think. Anyway, give it a try, see if you can spot them. In the eastern part of the sky, we've got the constellation Orion poking its head over the horizon. We keep raving about this constellation all the time, and it's no lie, it really is impressive. So have a look at that one. Down in the south, in the southern hemisphere, we've got the Southern Cross. Now, you can't really see the Southern Cross at the moment for most people, because where it is way down south, and it's sort of below the horizon for a lot of people at this time of year, and it's upside down. And if you go really far south, you should be able to see it just above the southern horizon, but for most people you can't. On the other hand, if you're sky watching in the early hours of the morning, not the mid-evening, but early in the morning, the Earth will have rotated and the Southern Cross will have come into view, and then you'll see it lying on its left-hand side about a third of the way up from the southern horizon. Now, to the planets, there are only 3 bright ones that we can see this month. As evening twilight comes on, you'll be able to see Venus high and bright in the west. I mean, you just can't miss it. It's the biggest, brightest thing once the sun goes down. It's really quite beautiful and spectacular. And at least for people, around the latitude where I live, sort of Sydney way in the southern hemisphere and thereabouts, Saturn and Jupiter are pretty much directly overhead at the moment this month. So they're very easy to see as well. After Venus, Jupiter is the next brightest thing, and Saturn is just right next to Jupiter in space terms, a few degrees away, and you shouldn't have any trouble seeing that one. Mercury, one of the other planets you can normally see, it's lost in the solar glare this month because it's heading around the other side of the sun from us, so we can't see it. Mars has been around the other side of the sun for a while now, and at least for the first three weeks or so of November, you just won't be able to see it. It's still lost in the solar glare. Right towards the end of the month, if you're very lucky and you've got a good clear eastern horizon, then just before sunrise, you might be able to spot Mars as a tiny little red star-looking thing just a few degrees above the eastern horizon before the sky gets too light with sunrise.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine.
And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.